Okay, you guys over there in Zoom, can you hear me? Okay. All right, so today is the 30th. Okay, Albright is here. Karen? Here. Champ? Chavez is here. Heroes? Here. Johnson? Here. Jones? Here. Martin? Here. Meloy? Here. Mohammed Boy? Olson? Richardson? Sisson is here. Varney, Vasquez, here. And Weflin. All right. So, chapter 4. Oh, before I start with chapter 4. So, your first test is scheduled for next week. And that test will cover chapters 1, 3, and 4 that we're going to do right now. And what I'm going to do is, I think I've graded assignments 1, 2, and 3 already, but I think I need to send you guys, have I sent you guys your assignments? I mean, graded assignments? Email? No? Okay. So I'm going to do that. I'm aiming for today, later on this evening to do that. So that you can have that to help you to review for your test. I'm also going to post the answer keys for all these assignments in Canvas as well, so you can have that to help you to study. So basically, I would suggest that you review all those assignments, and of course, you know, the questions that you'll find in the textbook, the end of chapter question, all right? I would suggest that you try to do as many of those as possible. And I'll be available for help as far as my officers are concerned, so you can contact me or come by my office for that purpose. So as far as the test is concerned, it will be available in the testing center, all right? And you can go to any one of the testing centers here or Ocala or Levy, whichever is convenient for you, all right? The only thing that you need to bring to the test is a pen to write with and a calculator, and everything else will be provided for you there. The test paper, the tables, like the periodic table, etc., that will be provided as well, and you should be provided with an extra sheet of scratch paper to work with, all right? And my understanding is that the way the system is set up now is that you go online, the testing center online, and you set up an appointment, all right? There have been some issues with that in the past, but I think that's basically how that works. So I would recommend that you do that as soon as possible. And I'm going to send over the test to them later on today with the expressed time frame being from Monday of next week to that Friday of next week. So you have the option of making an appointment next week between those dates, all right, to do the test. And I think that's it as far as that. Oh, and so what I'm going to try to do as far as the test format is concerned, since there are 4 chapters that the test will cover, I'm going to make it 4 questions, right? So basically it's a question per chapter. But of course, the questions will have different parts, kind of similar to what you would see in your assignments, right? So question 1 would have A, B, C, and so on and so forth. And I think that's it. Any questions about that? Any questions? Any questions? All right, so let's talk about chapter 4. The main topics, chapter 4 covers elements, atoms, and so on. But the main thing I would want to focus on in this chapter is basically the fundamental particles of the atom, and some terms that are related to that. So for each element, if you consult any periodic table and the videos that were recorded and posted that you should have watched. Basically talked about briefly some introductory comments about the periodic table, that it was first put together by a Russian chemist by the name of Dmitry Mendeleev. And I won't go into the whole story about that, but basically what he did was that he arranged the elements. He found out that if he arranged the elements according to their atomic masses, then after so many elements, you see some repeat properties. And as a result, he came up with this idea of putting elements that have the same properties in columns, and at the same time arranging the elements in terms of rows, in terms of their increasing atomic masses, right? And he used atomic masses back then because back then nothing was known about the structure of the atom. So therefore, he did not know that you could actually arrange them in terms of the number of protons, because the protons were not discovered back then. So he didn't know about that. Anyway, after so many years, the different fundamental particles were discovered. One of them would be the protons, and the elements were actually defined based on the number of protons, and that number is called the atomic number, right? So by definition, the atomic number represents the number of protons in an atom of the element. So hydrogen has an atomic number of 1 because it has 1 proton, and so on and so forth, all right? So each element has its own unique atomic number, right? So for example, nitrogen is the only element that has the atomic number 7. There's also another term, and by the way, the conventional symbol for atomic number is Z, all right? Another term that you need to be aware of is what is called the mass number. Now, the mass number takes into account another type of particle that is present in the nucleus of the atom, and that is known as the neutrons. In fact, the mass number is the sum of the total of protons and neutrons present in an atom. And convention is that A is the letter that is used to represent the mass number. So if you know the atomic number and you know the mass number, then you can easily calculate the number of neutrons, right? The number of neutrons would simply be the difference between the mass number and the atomic number. Now, as I said before, each element has its own unique atomic number. However, that is not true as far as the mass number is concerned. In fact, you can have the possibility of 2 atoms of the same element having the same atomic number, but their mass numbers are different, right? And they are called isotopes, right? They're the same elements. In other words, they behave chemically the same way, and we know they're the same element because they have the same atomic number, but the atoms are different because their masses are different. And we have 2 examples right here of isotopes. This one is called chlorine-35. This one is called chlorine-17. They both have the same atomic number, but you'll notice that the mass number, which is the sum of the number of protons and neutrons, are not the same. Here we have 35, here we have 37. So based on what we just discussed, you should be able to answer these questions. The first of which is, how many protons are there in chlorine-35? 17, very good. How many protons are there in chlorine-37? 17. How many neutrons are there in chlorine-37? I'm sorry?
20.
20, exactly. So that's basically how that is done. Okay. So this is just some comments about the fact that the elements are arranged in order of atomic number, which is a switch from, as I said before, what Mendeleev did. He did it in terms of atomic mass, but the same trends are observed. What you'll find is that in the periodic table, elements belonging to the same column, which are called groups, behave chemically very similar. So we have these elements here, which is in the column to the farthest right of the periodic table. They're known as noble gases or inert elements. And what they all have in common is that they're very unreactive, right? In fact, in the case of xenon and krypton and argon, in order for them to react with anything, you have to apply some special conditions. And as far as I know, nobody has been successful in making helium or neon reactive at all right? And if you consult other groups, you'll see that there are other chemical similarities that they share, those elements within those groups. Okay, let me see here. Okay, so I don't think there's anything else much I want to say. This chapter is a relatively easy chapter to understand. Let me just check out something here. Okay, briefly talks about chemical formulas, but we're going to deal with that in more detail. All right, so what I'm going to do is give you this assignment. And this assignment is based on what I just talked about, the relationship between the atomic mass, or I should say the mass number. Oh, let me say one more thing before I give you this. So if you look at any periodic, any legitimate periodic table, you'll see that for each element, there are two numbers associated with it, right? One is what I mentioned before, the atomic number, which gives you the number of protons in the atom, right? And again, let me emphasize that each element has its own unique atomic number. Now, the second number that you notice there is what we call the atomic mass, all right? Very often, especially students learning this for the first time, and even some seasoned scientists confuse the atomic mass with the mass number, all right? The mass number is, as we said before, the sum of the number of protons and neutrons. The atomic mass, as you see there, for example, in the case of carbon, is 12.01. That represents the average atomic mass of a carbon atom, all right? Two different things, mass number and atomic mass. Please do not confuse the two, all right? And one thing that would probably help for you to make the distinction between the two is that the mass number is an integer, right? Because it gives you the number of protons and neutrons present. The atomic mass is, well, has some decimal numbers because it's actually a measured value, all right? So those are two different things. All right, so with that said, let me hand you this. Basically, it's a table to complete, and it's basically testing your understanding of the relationship between mass number, atomic number, number of protons, number of neutrons, etc. Right? And this is for you, sir. And of course, I'm here to help if you have any questions. And for those of you out there in Zoom, I almost forgot you guys. What I'm going to do now is publish this assignment. Where is it? Okay, let me go files, assignments, and let me publish it right now. So you guys can work on this right now, and feel free to ask any questions that you may have, all right?
What if we don't have like numbers for how many, like, we have the protons, right? For example, there's one that says 53, right? That's the proton. How do you figure out the electron so we can find?
Oh, okay, good question. So in any atom, in any neutral atom, the number of protons and electrons are going to be the same.
So the proton and the electron will be the
Exactly.
same.
So in this case, you're talking about this one, right? So in this case here, you're going to have 53 protons and 53 electrons. Because that's basically what happens in a neutral atom. All right?
And do you like add those to find
No.
the joints?
No, I don't subtract anything. You just write down those numbers because you get them directly from the periodic table. Now for the well, not in this case, but if you're asked to find the mass number, for example, in the case of tin, right? Well, the mass number would be the sum of the protons and the neutrons. And we know that this here, 50 for the electrons is the same as 50 for the protons. So therefore, the mass number would be 50 plus 69, and that would go here. All right?
The sum of protons and neutrons.
I'm sorry?
That summarizes the sum of protons and neutrons.
Exactly, yeah.
How do we get the number of protons again?
Periodic table, you look at the atomic number. So which one are you looking at?
Tin.
Okay, so in the case of tin, well, actually, they gave you the number of electrons here. So that would be equal to the number of protons, which would be equal to the atomic number. But you can also look at the periodic table. You see tin here? See tin? In the periodic table? SN, yeah. 50. Ah. See? Right. So that would be the atomic number, which would be the same as the number of protons. All right?
The protons, electrons, and the atomic number are all the same.
Right.
I don't see why.
Yeah. Yes, sir.
How to get the neutrons?
I'm sorry?
Can you remind me how to get the
Right. So to get the number of neutrons, that would be the difference between the mass number and the atomic number. Right? The mass number and atomic number, the difference will give you the number of neutrons.
It's the max number subtracted by protons, right?
Or the atomic number, same thing. The difference between the mass number and the atomic number is the same thing as the difference between the mass number and the number of protons. Yep.
For calcium at the very bottom, how are you supposed to figure out the max number of neutrons if you don't have either?
At the very bottom, you can't. You have to leave those blank. Because in order for you to get the mass number, you need at the very least the number of neutrons. And exactly. So you have to leave both the mass number and the number of neutrons blank. Exactly. What's that?
Good to know that those are in here.
Oh, okay. I think there's like 2 or 3 of those. Let me see here. So calcium is one of them, and the other one is beryllium. Where is beryllium?
It should be 2 above silicon.
Oh, yeah. That too, yeah.
So either one works.
Yeah, because I put for mass number the sum of protons, neutrons, and neutrons is different, so yeah, mass number and electrons.
So copper isn't on the periodic element, it's because of the mixture.
No, it's an element.
Yeah, it's 29, right there. See,
Cu.
29. On group 11, column 11.
Oh, I see it. Here.
It's good. I'm sorry?
Well, we don't have anything else to do.
No, that's it. I'm sorry? That's the difference between the mass number and the atomic number. Yeah, if you can finish it before you leave, I would really appreciate it because I need to grade it and get it back to you. And by the way, so next week, for next week's class, make sure you watch the videos for chapter 5. I've published it. So make sure you watch them because we'll be working on problems for that chapter next week. All right.
What was the number above the symbol?
I'm sorry?
What was the number above the symbol?
The larger number would be the atomic number and the larger number would be the atomic mass. That's not the same thing as a mass number.
The number above the symbol is the mass number. Right?
Yeah, it depends on the periodic table. In your periodic table, which one is the larger one? The one above or the one below? Okay, so that means that the lower one would be the atomic number. Right.
There's 3 of them that you can't actually finish.
Hmm?
There's 3 of them that you have to leave incomplete because you can't assume the mass number.
Exactly, exactly. Let me see your periodic table.
One in the book, probably not.
Right, so the lower number would be the atomic number. And the higher one would be the atomic mass.
This is
Hmm?
the 32 for the atomic number. You said the one on the bottom is the atomic number, right?
The lower one.
The lower one is the atomic number. So that's 32.07.
No, that's atomic mass. And when it's a lower, I mean lower in value. So like,
Oh, gotcha.
so the atomic number in that case is
Got it.
16%.
Got it. Mass they can come up against, they don't know the nickel.
Nickel,
Right.
yep, atomic number for nickel is 28.
And mass number.
Let me see what we're dealing with here. Okay, which one is it now?
What about zinc?
Okay, so the atomic number is 28, right? And they gave you the number of protons. Well, that's 28 as well. Oh, okay, so you don't have the neutrons, you don't have them mass numbers, so you can't find out,
Either of them.
right? So you have to leave those blank.
Right.
Yeah. You cannot find the mass number without the neutrons or vice versa.
Right.
Me too. Hmm. Oh, okay, no problem.
Say everything on his.
No problem.
Neutron to helium is 0.
Sorry?
Neutron to helium is 0.
Or,
Helium,
well, no, that's hydrogen.
hydrogen.
Yeah, mhm, that's correct.
He is helium.
Yep.
Energy is magnesium.
For those of you out there in Zoom, I have created a Dropbox for the submission of this assignment. So if you prefer to submit it that way, the Dropbox is available for you. Just make sure that your assignment is submitted as a PDF document, very important. All right, and if possible, if you can submit the document as one document and not several pages each being a document, all right?
what the test is?
I guess, I don't really begin with.
Yeah.
Oh, okay, so I'll be sending the test over. It will be available for you guys at any of the testing centers from Monday to Friday next week. So the way this works, I don't know if I've done tests over there before, but you have to go online and set an appointment, and then you go there that day. And basically, I'll provide, or they'll provide the test paper, the tables, remember the same tables, cannabis, and sheet of scratch paper. The only thing you need to provide is pen and the calculator, that's it.
And if, because I don't know, I think next month
Mhm.
I might be moving away. Is there a way I can still take the test online somehow?
What I would suggest, because I've done this before, wherever you're moving to, if there's like a college nearby with a testing center, because sometimes what happens, well, what you should do, because I have some issues with that. What you could do is check all those colleges and explain to them the situation, and ask them if they're willing to have you be part of the deal. You know what I'm saying? And then come up and then we can arrangements to send the test over.
Okay.
All right?
All right, thank you.
Yeah, no problem.
Have a good day.
You too. Okay, Mr. Weflin, can you hear me? Okay, so you're asking about the test next week? Um, what do you need to bring? The only thing you need to bring in person is your pen to write with and your calculator. Everything else would be provided. The test, the tables, and a sheet of scratch paper will be provided. Just a regular scientific calculator. Um, that calculator should be okay as far as I'm concerned. Yeah, that's it. If you have completed and submitted the assignment, that's it for today. Yeah, you too. Uh, yes, you have to take it at the testing center because we'll still be having regular class next week. Okay, you too. Okay, so if I'm not mistaken, you're talking about those elements for which you cannot find the mass number, right, Mr. Sisson? Okay, so in that case, you have to leave them blank. Because if you don't know what the if you don't know what the mass number is, you cannot tell the number of neutrons and vice versa. No problem. Oh, let me see here. For assignment number 2, I was given I guess you can do that. I don't know if you heard, but what I plan to do is I plan to send back to you guys by email your graded assignments. So I'm going to get working on that later on today. You should get it between this evening and tomorrow morning. And I'm also going to post the assignment keys in Canvas as well, so that you can look at that and compare it to your graded assignment. Okay, you too.